The hashtag, I'm gonna forget. Give me the hashtag, and I'll put it for tomorrow.
Hashtag you hate me.
Miss, I'm not gonna.
Hashtag Friday Eve. Friday Eve.
Okay, hashtag Friday Eve.
Hashtag I'm ready for being happy.
All right. All these questions, guys, that we have here are all AP questions. Put the percentages and let's see how they are. You're gonna need a calculator eventually, not for these. This is a no calculator question.
7% correct. Wait, guys.
All right. Let's hold our horses. Question 7. Let's see what it says. And we'll warm up together. A particle moves along the x-axis with velocity given by blah for time t greater than or equal to 0. If the particle is at position 2 at time t equals 0, what is the position of the particle at t equals 1? So all this is not necessarily what we've been doing in analysis. It's just everything that we've been doing. So that's why I put, like, what do we know so far? Don't worry. The stuff that we've been doing is coming up in a little bit. All right. So how do I get position from velocity? Yeah. Perfect. Antiderivative. Do you guys remember when we did that? So this is motion in the x-axis, right? So okay, for good notes, let me write antiderivative of velocity is position. Antiderivative of velocity is position. Cool? So what is the antiderivative of 3t squared? T cubed. Chav, Ms. Vega, how'd you do that so fast? She added 1 to the exponent and divided by that exponent. She did the opposite of power rule. Opposite or inverse operations of power rule. So remember in power rule you multiply and then divide? Okay, reverse the order. Add to the exponent. Oh, did I say divide? Okay, power rule. Multiply by the exponent and then subtract. So reverse it and do the opposite. So add 1 to the exponent, and then instead of multiplying, we're going to divide. So 3t cubed divided by 3 is just t cubed. Does that make sense? Yes. All right. We're still going to continue. Plus, what's antiderivative of 6t? So add 1 to the exponent. What's that? And divide by that number. What's 6 divided by 2? So I write 3t squared. And then there's nothing there, so I got to go plus what? C, for some constant c. Chav, how are we going to find c? Well, look what they told us. If the particle is at position, what position am I at? At what time? That's what I'm going to use. I'm going to go 2 equals 0 cubed plus 3 times 0 squared plus c. So from that, I get that c equals 2. Does that make sense? So now, here's what I do. X of t equals t cubed plus 3t squared plus 2. I'll slow down. That is your position equation. What do they want? The position at what time? At 1. So now we're just going to plug in. X of 1 equals 1 cubed plus 3 times 1 squared plus 2. What's 1 plus 3 plus 2? There it is. That's it. That's fine. So what do we learn from these percentages? So it looks like, let's see, yeah. It looks like to me, just looking at the percentages, it looks like anyone who's qualifying is getting this one correct. So that's how you can give yourself, like, am I in good standings or am I not? All right. This question 76, this is actually a calculator question. But look, hold on, before you answer, before you look at it. Do you need a calculator for this one? No. Take a minute or two and see if you can get this question correct. Give me the definition. Don't give me the answer yet. F is increasing when
F prime is positive.
When F prime is positive. This is how you say it. All right. What's the answer? From -2 all the way to 3. Perfect. Yeah, that's the answer, guys. I know it touches it right at 1, but there's no sign change. So that just means I just have a horizontal tangent, probably something like this. But see, it's still increasing. What do we learn from looking at the percentages? So from looking at this, it looks like everyone but the ones is doing okay. So only the ones are in bad shape. The 2s, 3s, 4s, and 5s definitely got this one down. Does that make sense, guys? All right, let's go to the next one. How do we feel so far? All right. Now, this is like the activity that we did with matching. Remember what we did a few days ago, earlier this week? I think it was on Monday when we did F to F prime. That's exactly what this is. Take about a minute or two. See if you guys can figure this one out. If you're on the verge of getting it correct, keep going. Let me just give you hints of what I would do. The very first thing I would do is I would look at how many horizontal tangents I have on the original. I have 2 horizontal tangents. So that means on my derivative graph, I better touch the x-axis how many times? Twice. The first thing I'm deleting is letter C and letter E because those do not come even remotely close to that. Does that make sense? The next thing I would do, I would look at this and I would be like, okay, I better be touching the x-axis roughly about there to the left of the y-axis and there to the right of the y-axis. So the next one I would delete would be A. So now it's between B and D. Remember, those are derivative graphs. This is derivative, F prime and F prime. The next thing I would do, I would say, well, to the left of this horizontal tangent, I am increasing because remember, you read a graph left to right. So I better start above the x-axis on my derivative graph. Does that make sense? So which one must it be? B. It looks like, by looking at the percentages here, again, it looks like it's the same story. So everyone that's getting higher than a 1 looks to be doing this question correct, and then the ones are just not even in the. Okay. So, well, no, guys, look, check it out. Look, we've done already 3 questions. Does it look like this exam is hard? No, they're not. All they're doing is they just want to know if you know calculus. That's it. They're not giving you the hardest questions. The hardest questions are here in this class. The delta math that we kept going over and over and over. The hardest questions are in this. Yeah. But notice all they want to know is, do you know calculus or not? Do you guys see that? So start to believe, yes, you can do good on this exam. And they don't take a whole minute. All right.
Unlike the delta, bro.
Let's go to the next question. And this one is no calculator. So do you guys want me to give you guys time?
Yes.
Okay, take about a minute or two. Yeah, these are no calculator. Just do number 20 for now, guys. If you're close, keep going. I'm going to go ahead and get started a little bit on this. Before you begin, you got to know a few basics. Do you know what a point of inflection means? What does it mean? When what goes from positive to negative? No. F prime prime. Perfect. Do they give me the second derivative? So from that, give me the zeros of that line. Call that F prime prime. Do I have to worry about the x squared? No. It's always positive because it's x squared. Do you guys see that? Yes. Pick any number to the left of 0. What number is easy for you? Negative 1. Negative 1. All we care about is the sign. Negative 1 minus 3. Is that positive or negative? Negative 1 minus 6. Positive or negative? Negative times a negative. Positive. Okay, give me a number between 0 and 3. 1, 2, it does not matter. So if I choose 2, 2 minus 3, positive or negative? 2 minus 6, positive or negative? Negative times a negative. Positive. Okay, give me a number between 3 and 6. 4. 4 minus 3, positive or negative? Positive. 4 minus 6, positive or negative? Positive times a negative? Give me a number bigger than 6. 7. 7 minus 3, positive or negative? Positive. 7 minus 6, positive or negative? Positive times a positive. Tell me where I have points of inflection. 3 There it is. Do you see how we did it?
Yes.
Okay, what's up?
Okay, the definition of points of inflection is where f prime prime changes from increasing to decreasing.
No, where f prime prime changes signs. If we use f prime, well, look, by definition, if f prime prime is positive, f prime is increasing. So if we had f prime, where f prime changes from increasing to decreasing, or decreasing to increasing, which, by the way, is a maximum on f prime, it's an extrema, or since I have the second derivative, where the second derivative changes signs. Cool? Okay, before we start this one, guys, this one's probably the hardest one we're going to do today. By the way, Miss Kyle, look, check it out. About number 20, the one that we just did, look at the total percentage of students that got it correct. This is considered a pretty hard one. Look at number 20. 73% of the fives got it right. So I would say that's pretty good. But look at the big drop off between the fives and the fours. Only half of the fours got it right. And look, the threes are barely surviving. So number 20 would be considered a hard one. But if you guys are able to tackle it, if you got this question correct, I would say you're in good company. Now, before I do number 21, I want you to notice on number 21, even the fives are having a hard time with it. Oh, look, 22% of the total population got this question correct. So that means 21 is considered a pretty hard question. Take about a minute, maybe two, and then we'll see why it was so tough. No calculator. No, let's see. All right, I'm gonna go ahead and get it started, guys. Let's see. A particle moves along a straight line. The graph of the particle's position x of t at time t is shown above between 0 and 6. The graph has a horizontal tangent at t equals 1, so horizontal tangent, and a horizontal tangent at t equals 5. And a point of inflection at t equals 2, so I'm gonna put a point there. For what values of t is the velocity of the particle increasing? Okay. I'm gonna show you a hack, and hopefully you'll never see this type of question the same ever again. There's actually a whole bunch of these all the time. This is a play on words. Chav, what does that mean? Change the position, velocity, and position, velocity. Instead of saying position and velocity, let's change it to something that we're really good at. So the position, instead of calling it x of t, guess what I'm going to call it? F. And when it says velocity, guess what I'm going to call it? F prime. Now let's read it again. A particle moves along a straight line. The graph of the particle's position f at time t is shown above between 0 and 6. The graph has horizontal tangents at 1 and 5 and a point of inflection at 2. For what values of t is f prime increasing? So I want to know where f prime is increasing. This is f. Okay, let me write this down. Maybe you'll see it real quick. If f prime is increasing, what does that mean about f prime prime? Yeah, f prime prime is, okay, this graph is f, right? Where is f prime prime positive? Oh, well, yeah, but tell me the interval where f prime prime is positive. So there it is. Between 0 and 2, I have this happening. Do you guys see that? So the answer to this is, do you guys see why this one was so hard? All right, tell me. Oh, okay. Yeah, okay, this is what's happening, guys. So it's because you guys are thinking more like physics instead of, so what's happening is this. If I were to graph my velocity graph, see how it decreases and then increases, the F increases, decreases, then increases? It probably looks something like that initially, velocity. In physics, you probably say, oh, velocity is decreasing because the speed is decreasing, but velocity is a vector. Is this curve not increasing? Is that curve not increasing? The velocity curve? So there it is, velocity is increasing. Even though the quote unquote the speed is getting slower, The velocity is
Of
increasing.
F to find F prime.
Does that make sense?
F prime.
It's okay if it doesn't.
I guess that's why it's a hack.
Oh, you got it right. Oh, sorry. See, so you're in good company, miss. You're in real good company. Kyle, what did you think? What'd you think? Did you like this? Do you like to play on words?
Heck no.
Oh, you don't like to play on words? So you got it right from the beginning. Oh, but did the play on words help? Like the F and F prime?
Yes.
Okay, that's what I meant. Like, did you like when I substituted F for, okay. Did you get it, Vega? Do we understand this question, guys? Yeah, it's hard. Even physics kids are getting this one wrong. Because they got to remember that velocity is a vector. But professors do it all the time. The velocity is getting closer to, like, velocity, the magnitude of the velocity is getting closer to zero. And professors say all the time, oh, velocity is decreasing. Okay, I'll stop. Are we cool? Okay, let's go to the next one. This one is a calculator one, guys. Grab a calculator. Grab a calculator, guys. If you don't have a calculator, get a calculator. Take about a minute or two. There's a calculator in the back there. All right, take a minute or two, guys, for number 78. Do you have your calculator? Yes, go get math stickers. For Christmas, if you guys get a chance to ask for a calculator for Christmas, that's what I would ask. I did ask for a calculator.
Last year.
For a calculator for Christmas, and look, and now it's paying dividends.
This is my first purchase when I got a job. I love that.
Yeah, me too. I love that, miss.
Who said that was sad? Well, because she behavior. That check is in it, yeah. It's the
I can see a lot of you guys typing it in. You guys probably already know what to do. I'm going to start reading it. The first derivative of the function f is defined by, and they give me this function. What intervals is f increasing? Okay, give me the definition. F is increasing whenever. Perfect. So I'm just going to type this into my calculator. Let me go to y equals. And let me show you guys how to fix your table and everything. A window. I'm just going to type sine x cubed minus x. So sine, bless you squared, bless you cubed, bless you to the fourth power, bless you to the fifth power. So there's my sine cubed minus sine of x cubed minus x. Is that what it was? Okay. See how it says between 0 and 2? So when you don't push graph, click on window and put x min 0, x max 2. Chav, what about the y value? Okay, we all took pre-cal. And it's okay, I guess, if you don't know this, but the number in front of the sign is a 1. That's a 1, right? So the smallest this will ever go, if it does, is -1. And the biggest it will ever go, if it does, is +1 for the magnitude. So go to y min and put -1. Y max, put +1. And that's all you got to do. And just push graph. And then there it is. Whenever it's positive, it looks like it's a perfect 1 right there. But I got to find this one. I just got to find this one on the right. Does that make sense? So I'm going to push. Let's see, what am I going to push? Second, calculate what number? 2, the 0. And then it tells me where do I want to look. I want to look between here, enter. And I want to look between there, enter. And then there it is. So 1.6906. So from 1 to, did it say increasing? Yeah. So from 1 to 1.6906. 1 to 1.6906. There it is. And it looks like on this one, everyone but the ones is getting this correct.
Wait, can you do that again?
Yes. So, by the way, you also have Desmos. So maybe maybe this one will be an easier one for Desmos because I like Desmos for zeros, but I like integration better with a calculator.
For both of these, do we have the calculator?
Yes. No. Let me see. What was the other one? Oh, yeah. Anything that has a number bigger than 20s, or yeah, you have a calculator. Okay, yeah. All right. Do you guys want a 2-minute head start for number 80? Okay. Also calculator. because what you just graphed there is the second derivative.
Right, but I thought if so it's asking for the points of inflection
Mhm.
of f, so wouldn't that just be the limited max
Of f prime? Yes, but you see how like it was. Yes, you could also find it by finding the min and max, but I feel like it would take a long time to be like max, min, max, min. You know what I mean? But that you can just tell real quick. Oh, like it crossed, and they just want to know how many times. So it's easier, in my opinion, it's easier to count how many times you cross the x-axis. You know what I mean? But you're not wrong though. You're right. You can do it that way
Because
too.
it also, because on the other one, whenever I graphed f prime, it didn't show me as many points as it.
Yeah, see, that maybe that's why they tried to trick you, because maybe we had to stretch the graph more so we could see it easier. But see, it's way easier like that, in my opinion.
Okay.
All right, on this one, guys, let's see what the percentage is. So this one, the percentage is kind of surprising. Notice that the ones and the twos and even the threes are really struggling. Heck, even the fours. Look at that. Why makes this question so hard? I think this is what I assume. I think kids just type this y1 into y1 and they just try to see where I have max and mins or where it changed from increasing to decreasing. So let me type that in. Look, so here it is. I'm going to clear it and give me the expression for the derivative.
X squared cosine of x squared.
Like that? Okay. X squared cosine of x squared. All right, check it out, guys. If I were to go to the window and I were to go, so Chav, what's your how do you do it this time? My x min is -2, my x max is 2. So x min -2, x max 2. And what about your y min? Well, I guess if I'm using the same logic as before, I can see that if I plug in a -2 in here, -2 squared is 4, and then 2 squared is 4. So this is going to go between like positive -4 or something like that. Maybe not. So I'm going to go with -2 and 2. Or if I need to go with 4 and 4, -4, I will. So here's how it looks. There's my derivative. Increasing to decreasing. So there's 1. Decreasing to increasing, 2. Increasing to decreasing, 3. Look, I only count 3 right here. But that's not the right answer. The best way to do it is to do it with the second derivative, where it crosses the x-axis. So that bet you that's why so many people got tricked. Look, guys, you have a calculator. Tell the calculator to do it for you. Or you have Desmos. Tell Desmos to do it for you. Don't worry. We will practice with Desmos in a little bit. So here it is. I'm just going to turn off y1. I go to y2. And here's how you do it, guys. I push math. I push number 8. See how it says derivative there? And then I push x. And then right here, I push y1. Alpha trace y1. And then x. Yeah, you guys practice with me. Do that. Yeah, if you're using Desmos, if you already have the top function as f of x or f prime, just put f prime prime and it'll do it. All right, push graph. And now we're just going to count how many times it crosses the x-axis. 1, 2, 3, 4. How many times? 5. Yes.
Why doesn't it work when you find the second derivative first?
I didn't find the second derivative. The y2 is the second derivative.
No, yeah, but why isn't it? It doesn't
Oh,
get the same answer.
for the y1? No, it does. It's just that I would have to stretch y1 to really, because it's kind of like it's squeezed in, so you really can't tell when it's going up and down. Because you know what I mean? Yeah, you can't really see it on f prime. Like, oh, you can see the ones that are obvious, but you can't see the others. But if you do that, then you see it a lot better. And then I would turn this
Yeah,
one
but you said
off
you have to stretch it out.
because that's where the original one is. Yeah, say it again.
Couldn't you just count the maximum?
Well, that's what. Yes, but because it's squeezed in so much, like it does. Not all of them show up. You know what I mean? Sorry, I'm gonna have to wait right now.
Because I was.
Oh, you work? 1, 2, 3, 4, 5. Well, but what if they squeezed it in more?
Yeah.
You know what I mean?
Okay.
But yeah, I guess you could. I guess you can. But be careful though. I guess that's the way like to verify it. What's up? Yes, back there somewhere.
Chop, do you have Delta?
Say it again.
Do you have Delta?
No, I didn't give you guys Delta. All right. Is that the last one? Okay. I do have UH quizzes, guys. Let me go ahead and add them here.
What are they doing?
Not until after Turkey week. UH quiz.
We're chilling.
UH quiz 13, which I believe is called concavity. And let me get the other quiz. Extrema. These two are active, guys. At the moment, let's put the due date for December 3rd. Yeah. All right, guys. I want everyone to focus real quick just for a little bit. So we have two UH quizzes that are open, 12 and 13, and both have the due date of what? So unofficially, it's not turkey work, but I would like for you to take care. On Turkey Day, don't do any work. Like, be with your family. Don't do any work on Turkey Day. Spend those moments with your loved ones and relax. But maybe for Black Friday, maybe you don't need to go shopping. Maybe you guys can. All right. That's it, guys.